Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Every week we present a session on Python or machine learning. Tonight we'll be doing some Python, and we do it online or in person. So next week will be an in-person session. It'll be our final session at Brisbane Business Hub on the Queen Street Mall in Brisbane. So yeah, if you want to come along to that venue, then next week is your last opportunity to do that, because they're moving and they don't know if they'll have a room like that at where they're going to. But for our online sessions, which we're doing tonight, we're doing live, so you can ask questions during the session. So you can ask questions either on the YouTube chat, which I see Slade's already sent a message, and we'll also be watching Learning to Code in the Beginners Python Slack channel. There's instructions on how to get into Slack channel below this video in the comment in the information. All right, now we're going to be using Google Colab tonight. So it means you don't have to have Python installed on your computer. You will need a Google account if you want to save it, but it means you'll be able to follow along. And I've created a notebook for you, so you don't even have to do much typing. And the link is here. It's either in the information below this video or on the meetup page. So if you click on that link, it'll take you to the shared Google Colab notebook. And you'll notice that because it's being shared, you won't be able to save changes. It says changes will not be saved. So if you want to save changes, the best thing to do is click copy to drive just here, and then you'll be able to save that in your Google account. It'll get saved onto your Google Drive. All right, well, it's looking a bit messy. So let's close that, and I'm just going to refresh this page because it looks like it hasn't loaded properly. That's looking better. Okay, so Google gives us a VPS, a Linux VPS, that we can run some Python in. So we just need to connect to that, and they'll allocate us some RAM and some drive space, and we can save files, although they won't be kept after the session. In fact, even the outputs from the cells, I've turned that off. So if you want to keep them, then you'll need to change one of the settings there to say that you want to keep your output. I think that's in. It's not there. Anyway, one of those. All right, but most of the output is just you receive it from running the cells, so you can regenerate that output at any time. So a couple of weeks ago, Arun did a machine learning presentation where he was capturing data off websites, and he was actually taking screenshots and then doing image to text, character recognition, and getting the content that way. So it took out a lot of the technical difficulties out of doing this, but I thought if you want some more control, I'll show you how to do it using the more traditional way of looking at the structure of the data that's coming. So we're going to be looking at data coming in from XML, from RSS, from HTML, and we're going to use the beautiful soup library to get that a way of analyzing it and capturing our data. Alright, so this is a Google Colab notebook. It's made up of formatted text cells like this one up here, where I put a few links in for you, and some code cells. And the code cells is normally Python, but if you start the code cell with a exclamation mark or the line, with an exclamation mark, it'll actually jump down to the shell belowhand and run it in Ubuntu Bash. So the first thing I'm wanting to do is see if the Beautiful Soup library is installed in Google Colab. So I'm going to run the command line instruction pip list to give me all the third-party libraries, but it's quite a lot of them. So I'm going to run it through a filter. There's the pipe symbol there, and the filter is going to grep, which just means filter. So it's the name of a program that does filtering, and I'm just going to filter on Butte. It's a case-sensitive filter, but Beautiful Soup is actually spelled with a lowercase b. So Beautiful Soup 4 is installed already, 4.12.3, so that's going to be fine for what we're going to need tonight. Actually, we're also going to use LXML, so let's see if LXML is installed. And it is 4.9.4. Okay, so it's a beginner's session, beginner's Python. So if you've got any questions about something that I skip over, feel free to ask. But I'll just give a very brief explanation of what's happening, and then if you don't understand it, ask for more information. So when we're doing Python, we want to use libraries if we want more requests, capabilities than it comes with a standard language. So one of the standard libraries that comes with Python is URL-lib, and we're going to be using the URL open function to send requests off over the internet and get data back from web pages or XML feeds. So because it's a standard library, we don't need to install it. Here's some documentation. We're not going to be doing much fancy with it. If you wanted to do a lot of this sort of thing, it's actually quite a difficult library to use. Even the documentation for it recommends using a third-party library called requests. So that's what you could use. But anyway, it's pretty simple what we're doing. So let's run that cell by clicking the play button here. And now we can use the URL open function because we've imported it from that library. Now third-party libraries, they have to be installed unless you've got something like Anaconda or Google Colab where they've installed it for you, and we've seen that it is already installed. But if you wanted to run this session just on your normal Python install on your computer, you would need to pip install Beautiful Soup 4 and LXML, the two libraries that we're going to be using, and I'd always recommend to do that in a virtual environment. The documentation for Beautiful Soup is at crummy.com, and you can follow the link. They've got quite a good, it's just really, their quick start covers most of the things that you need to do with it. I find the order that they do them a little bit different to what I need to know, so I would normally be jumping right down to the bottom first and work my way up if you're trying to find something in there. But I'm going to cover a few different scenarios tonight, and maybe that'll be enough to get you going in what you need. Okay, so when we use Beautiful Soup, it can parse HTML or XML, but we need to have a parser in there. So we can use HTML.parser, which is just a standard low feature one, but if you've got another third-party library like LXML, then you can use that one. That's supposed to be quite good performance, and HTML5 lib is another quite good one that you can use. If you're going to do XML, then you need LXML, so we may as well just use LXML for everything, and that's what we're going to do. So our first thing to do is going to open up a URL and load everything into a soup, and we just use the Beautiful Soup constructor here, and we put in there the page, which the page is that reference to the URL open whatever that returns as some sort of file-like object, and we're going to say that it's XML. So let's have a look at what the data is going to be. So I'll just click on that, and you can see here this is what XML looks like. So it's pretty similar to HTML. They both come from a similar background. These are the tags here. So capital RDF is a tag, channel is a tag, items are a tag. So they're like your tags in HTML, like paragraph or table or body. What's a bit different is you often get these namespace identifiers out the front, and that's really just because XML data can come from lots of different sources, each of which has defined their own tags, and so they need to give some way of making their tag unique. And so in this case, this is using the RDF namespace, and then in the first attribute here it explains what that namespace is, and it's really just a URL. Hopefully if it's a URL you've got control over, like it's come from the w3.org organization, then they know it's always going to be unique because no one else can have a URL on their domain, and so this is the bit that's unique. That bit you can have RDF could be the same with different namespaces from different people. If that happens, then you've just got to change that bit, and you leave this bit here the same. So that's what makes them equivalent. And you can see they've got, RBA's got a namespace, DC's got a namespace, CB, whatever all these are. All right, and we've got an RDF, a channel, items, and then down here we've got each of these items has got an exchange rate in it. The exchange rate will give us something like here. So that's telling us that a CNY is 4.75. 4.75 CNY give you 1 AUD. So I think that's Chinese yuan. So here's the first one, the 0.6614 US dollars is equivalent to 1 Australian dollar. Alright, so that's how the data is coming on this RSS feed in an XML format. So how can we use that data? And so let's have a look at what Beautiful Soup can do for us. Alright, now I need to run these cells. You can see I've run the top one because it's got the number 2 in it, and 3. This one hasn't been run yet, so I'll run that. So now I can use Beautiful Soup. Let's go off to the RBA, get that XML and load it into a soup. And I've used the with command here so that it anything inside that with will keep the resource open and create the Beautiful Soup, store it in soup, and then when it jumps out of that and goes back to non-indented code, this context manager associated with the with will automatically close that resource. So with is a really good way of making sure that your resources get closed when you finish using them, because there's no way you can get out of them without not indenting your code. And so even if you got out of it using from an exception that got thrown, it would still close the resource. Alright, so the soup has been created, and then how do we use it? So there's a variable called soup. We can look for the first item tag in the soup just by saying soup.item, and let's print that out, and I'm going to use Prettify just to make it look a bit prettier. And there we go. So it's looking, that's the first item. As we saw before, it's the Australian US dollar exchange rate, and it's 0.6614. And I think if we look down here, we'll see the value. Here it is. There's the value of the exchange rate. Okay, task 1, find the first tag of cb.exchange_rate. Okay, so I'll just go, I'll go to my soup and I'll just find the first tag, and so I'm just really using it like an attribute on a class object, and that will find it for me. And so there it is, it's found it. I don't need to put in the CB when I'm using this format. I can't put in the CB colon because colon means something in Python, and so you can't use it here, but in this case it was unambiguous, so it returned exchange rate for us. Okay, so I've left a spare cell, an empty cell there for you to have a go at these tasks as we do them, so you can have a go as well, or you can just watch me do it. Okay, here's a solution that I provided earlier. It's showing that this solution that I just did above is equivalent to soup.find exchange rate, and so that's another way of doing it. So I'm just introducing you to different things that Beautiful Soup can do. They've got a find method on that soup object, and you just pass in a tag name, and with that tag name you could actually put the CB colon in because it's just a string, so the CB colon is not going to affect how Python interprets things. And there's the data. Alright, once you've got a tag, you might want to have a look at the text that's inside that tag. And there's different ways of doing that. You can use .text, or you can use .string, or you can use .strings. And text extracts the text from a tag and all its descendants. So let's have a look what that looks like. So this is soup exchange rate.text, and you can see there's all the descendants in this exchange rate. Some of them don't even have text, but they show up as a blank line, and some of them have got text. So it's just all that data has been extracted. If you use .string property, then that extracts the text from that tag only if it is unambiguous what could be returned. So for example, there's no subtags, or is exactly one direct subtag and it has a string, then it will return it in string. Otherwise you go for strings, and that'll give you a list of strings from all the descendants. So that's slightly different structure to text. Okay, display the string value for a tag which has a string. Okay, so let's go have a look at our documentation, and I would say that unit has a string, so let's have a look at that. So I'll just go to soup, let's find the first unit and extract the string from it. And AUD, that's the string that came from it. Okay, so let's have a look at the solution. The solution went into a bit more detail. It's used this descendants property of any tag. So soup is like a tag of the whole XML. Item is a subtag of that, but it behaves just like a soup, so we could just use it. The tag that gets returned from that will be just like a mini soup. And then descendants, so it can have descendants, and those descendants, each one of those will be a tag, and they could have descendants as well, and we can work on it like that. So we're going to do a loop through all those descendants, store it, that object into tag, and we'll just check that it's got a name, and we want to make sure that it's got a string. And once we've determined those things, then we will find its parent and the name of the parent, what the tag's name is, and what the string is. So let's run that. So these items have this item has got a title, link, description, date, language, and audience, and each one of those has got a string, and they're the strings that it's got. So it's using this descendants and parents is the metaphor that it's using so that you can understand the structure of the the way the data is in the XML. So if XML tags, we can see this is nicely indented, so it's easy to see that structure as well. So this observation, for example, has a type, a value, a unit, and decimals. So observation is a parent of all of these. These are children of observation. Exchange rate is a parent of observation. And you could say that type is a sibling of observation because they're at the same level. So exchange rate has descendants in the first level and the second level. They're all descendants rather than just children, which is just the first level. Okay, so what are we doing here? soup.targetCurrency.text extracts the text from the first target currency tag. So it's a really convenient way of referring if you want the first one in the soup. It's a bit harder if you want the second one. So let's have a look. So targetCurrency.text extracts the text, and it gave us US dollar. TargetCurrency.string also gives us US dollar because it's unambiguous. And let's see where we are. So target currency US dollars. And if we look in the actual thing here, target currency just has, so there's the text, and it is definitely unambiguous. We've been using find, which is like just soup.targetCurrency. It finds the first one, but sometimes we want more than that, and so we can use find all, and that'll find all the tags and returns them in a list. So we could find all the ones that have got a tag of item and store that in a list called items, and then we can just find out what the length of the list is, and in this case it's 19. Okay, so we've got a task here. Go through all the exchange rates by currency code and look up the rate that is Japanese yen. Okay, so what we want to do, we want to go through all of our items, and if item dot and the currency code, that's stored in a tag called unit. Then let's just print that item. Okay, and it didn't find any. And that's because I did lowercase. So let's do uppercase. And let's do a bit more. Let's try. Maybe I'm looking at the wrong thing. So our unit is always AUD, so it's the target currency I could look at. There we go, and there's the item that is a Japanese yen, and we can see 97.60. Look up the rate. Okay, so I actually want that value. And there it is, 97.60. So let's have a look at the solution that's been provided. So what we've done here, same sort of thing. We're looking up for each exchange rate. So it's searching all the exchange rates rather than items. I searched items, but we could have just searched exchange rates. It's looking at the value string and the target currency string, and it's using dictionary comprehension to actually make a dictionary of all of the exchange rates, not just Japanese yen. And then I'm going to print out that dictionary just so you can see what's been created, and then it will print out the what that rate is versus $1 Australian dollar. So there's the dictionary that got created. Japanese yen is 97.60, and then at the end it prints out $1 Australian dollar equals 97.6 Japanese yen. Alright, so we've been searching on tag names, and so tag names are this first bit of a tag. That's the name of the tag. These things in the angle brackets are called tags, and then also in that tag identifier we've got attributes. So any of these values where you have a key and a value, they're called attributes of the tag. So some tags don't have an attribute, all they've got is the text or string, but other ones have these attributes. So we can actually search on those attributes as well. So for example, I could look up soup.channel and say what is the attribute rdf.about, and it'll look at the first channel and say, well, that's the attribute for that that tag. And I can also find all of the oh, that's it for attributes. Okay. Now moving on back to tags. I said before the namespace qualifier is optional. Here's 3 ways of looking up an li tag. The first one has got the namespace qualifier in it, rdf::li. The second one's just got the li, and the third one's using a class property.li. And these class properties are dynamic, like depending on it hasn't been hard coded that there's looking for a thing called li in that class. It's just whatever that soup has become the class properties for that object. Okay, now keyword argument can be passed as a string, a list of strings, or a regular expression, function or true. So when we're finding, so this is the tag that we're looking for, but we also want to find any tag that's got the string JPY in it, and we're going to look at the parent text of that. So that's 97.60 is the text. So it's gone, looked for the target currency of JPY, it's found the parent of it, and then found the value tag within that parent and the text that went with that. If you want more help on these, as well as the website that I showed you before, you can just use the Python function help, and it tells you how to fill these things. So you can see the first attribute, the first argument is called name, and that'll be the name of the tag. We can then search on the string value, it's a specific one. We can say whether we want to go recursively, and then we can use keyword args, which is basically any other attribute values of those tags we can search on, but sometimes those attribute values might have a name that we can't use as a keyword argument in a Python function. For example, they might be using a reserved keyword of Python, in which case you can send a dictionary for the same thing and use so the dictionary, all the keywords are quoted as strings, and so they don't clash with Python keywords. All right, and you can do find all is another function, and it looks very similar. Okay, so we've been looking at XML. Let's have a look at some HTML. So the difference here, I've got a website here, and we're going to use a different parser. We'll use the HTML.parser rather than the XML parser that we used. So let's have a look at the website that we're going to go to. This is done by the ACCC. They check petrol prices all around the country. They're reasonably recent in their graphs. That's the Sydney prices. Unfortunately, the data in their tables, which is what I was really interested in, is not up to date. So the latest date they've got there is 4th of November 23 for Sydney, November 23 for Melbourne. But anyway, it'll still be able to demonstrate what we're trying to achieve. So we're going to find the buying advice. There's the URL for that site, and we're going to use URL open as before, give it the URL and parse it all into a soup that this time we're going to call ACCC. So that's gone and fetched the website, stored it in ACCC, and now we can do all the things that we want to do on ACCC without having to go back to the website anymore. So we want to look for H2 tags which separate each capital city data. So let's have a look at that. Find all the H2 tags, and we can see them here. Petrol prices in Sydney, Melbourne, Brisbane, Adelaide. We also got these other ones which have come in and they're sort of clouding it all. So let's why don't we put a filter on the class that's table of contents header, and we're not interested in the other headers, second level headings. And that looks a lot better. It just gives us Sydney, Melbourne, Brisbane, Adelaide and Perth, just the 5 different H2s. So that's a good way of getting to the part of the data that we're really interested in. Now the most reliable way is to search on ID, because IDs in an HTML page they should be unique on an HTML page, so there shouldn't be more than one, so there's no chance that if we go by ID that we'll get an early one and miss out on a later one, because they should all be unique. So we can search on ID just by using a keyword arguments like this, ID equals and what the name is, or we can use the attributes dictionary if, for example, ID was a Python keyword, and put it in this way. So let's have a look at Anchor Brisbane, and there it is. It's found the ID petrol prices in Brisbane, and that's a hyperlink, and it's actually an anchor. It's not taking us anywhere else, but if someone uses this anchor, they can come straight to this particular part of the web page. Okay, so what we want to do is navigate up to an H2 once we've got the anchor, and find the recommendation for Brisbane. So this is where we're a little bit dependent on them not changing the structure. So let's see. I'm going to press F12 here so we can have a look at the structure of this page, and we're interested in this H2. So this is the H2 that we're interested in. We've just done a search and we found an anchor, and it was what was it? Oh, that's where the ID was. Sorry. So there's the class, there's the ID for, it must be in here, so I'll expand it. There we go, there's the ID, petrol prices in Brisbane, and it's an anchor. So the H2 is actually a parent of the anchor. So once we've got the anchor, we can find the parent to get the UL. Well, in this case it's actually the H2, but then we'll just look under all the siblings until we find the unordered list, and once we've found the unordered list, then we can grab the text from that to find out what the current recommendation in Brisbane is. So there we go. Current recommendation in Brisbane is, while the price cycle is around a high point, we encourage motorists to use fuel price apps and websites to find lower price retailers. So even though we called this UL, it wasn't actually a UL. The parent wasn't a UL, but eventually we went through all the siblings until we found one that was a UL. Okay, so that was the code to do it, but there's actually an easier way in Beautiful Soup to do it, which is just find next sibling. And there we go, there's the same result. So task 4, find when the next low price is going to be. Okay, now I could just write out all this code, but probably get more value from me explaining what's going on. So we found the anchor, that was the A, that parent took us up to the H2, and then we wanted to find the next table. Now, previous time I did this, the table was a sibling of the parent of the H2, so I had find next sibling to go to that table. They've changed the structure now, so I've just gone for find next because there are no other tables that I'm going to find, so that's decoupled me a little bit from the structure that they've used, so now that will work with either the current structure or the old structure. Okay, once I've got the table, then I want to find all the rows in it, but I'm only interested in the rows that are in the T body part of the table rather than the heading, so I just want the content, and then I'm going to look at all the TDs in that row. So I'm going to go to the last row, so TRs -1. This is just standard Python lists with a -1 index, means give me the last one, and then that'll give me a tag, and now this is Beautiful Soup. Find all the TDs in that last row, and then I can do some conversions. So I can convert the previous low. I can parse that to a date time. I can look at the days in the cycle by doing an integer of the string value for the in index 4, and the current date low will be, or the next date low will be the previous date low plus the number of days in the cycle, which I've just calculated, so I can predict the next low. Now, because I haven't got the table up to date, that's not going to help me much. It says the predict the next low is the 9th of November 2023, but you get the idea. Okay, task 5, find the date of the last low price for every city with a name ending in E. And I've got a hint here, try using regular expressions. Alright, so regex101.com is a good way to practice your regular expressions. So let's jump over there and see what we can do. And we'll have a look at the answer here. So I've got a regular expression here. That's my regular expression that I'm compiling using the regular expression library, and then I can just pass that to the argument of the find all function, and it will know that I'm providing a regular expression, and it'll use that in its finding. So I'll paste my regular expression. I'll say I'm doing a Python regular expression, and I want to see if it works for petrol So here it says the regular expression does not match the subject string. So what this regular expression, and this will even explain to you what is happening. The start of the string has to, the circumflex there says I want it to start right from the beginning, so petrol, prices in. It wants all that text like that. Then \W is any word character, so that's any of the letters A to Z or the numbers or an underscore. And the asterisk means as many of them, 0 to as many as you want. But finally I want an E, the letter E, and Sydney doesn't end with an E. Now if Sydney was to be named that, then yeah, say that is a match. The first 22 characters matches that regular expression. So I can see that I've now said I want a regular expression. There's one ends in there's Brisbane. So but if Brisbane didn't have an E on the end, then it wouldn't match. So that's just a way of doing a regular expression to match city name ending in E but starting with petrol prices in. Now you can see in here regular expressions use the \/ character for escaping their special characters. So W is a special character, to say a word character. Unfortunately Python also uses a \/ character to escape things, and so if you want to provide a \/ character to a regular expression, then you would have to escape the \/ where you end up with a double \/, and that's a problem Java has as well. When you're doing regular expressions in Java, you got all these double \/, and then when you do want a double \/ you got 4 \/. So it becomes very, very confusing trying to read it. But Python makes it a lot easier. They give you an R way of specifying the string, and an R string, it says I'm not going to use \/ for escaping. I'm going to keep them literal, so therefore that's really good for regular expressions, because then the \/ you see are really just for the regular expression, not for anything else. Alright, and then they say always use an R here. Alright, so you can see I've put an R here in front of the string so that I can use this regular expression. Alright, so I'm going to find, that's going to find all the anchors. Then I'm going to look at the title attribute, look for a space, and then find the city that's after that. So RE is not defined, and that's because I didn't run this cell up here, so let's run this one first. Import the RE. RE is a standard library, we don't need to install anything. And here we go, here's our last low price in each of these cities. So what's the title? Let's just have a look at what the title was. So here's the title, petrol prices in Brisbane. Oh, and that's what I did. I did an rfind. So the rfind finds the rightmost space. So it's the last space in the string, and there I knew the city name was going to be after that. Okay, now task 6. From the RBA website, find the full name of the currencies IDR and INR. Well, this is an interesting one, and they've actually changed the website since I first set this up. So we're going to have to do a bit of a change in how we tackle this. So this is what the website looks like. It's got latest exchange rates. There it says what the different currencies are. And if I press F12 and click here to select a particular element, so there we go, I've chosen the United States dollar. And I can see here that even though USD is not in the list anywhere, they've used the 3-letter code as the ID for the row. And I go, well, that's really useful. Now I've got a way of looking up a 3-letter code and finding out what the name of the currency is. So let's try that. So here's my solution. I'm going to find the H2 in the exchange rates, find the next table, find all the rows. Or in fact, that line here was not in the original solution. I'll just put that in to have a look later. So I want to find all the rows, and I've put the filter here. I want the row, the TR ID, to be IDR or INR. So let's run that. So it's got to go to the site and get the whole page, and it hasn't returned anything for us. Okay, so let's try to debug what's going on here. I'll disable that one because that'll make it a bit faster. I don't need to go back to the web page. I've already stored it in RBA HTML. But let's have a look at an H2, and I'll have a look at the table and row 3 and just see what it looks like. Okay, and it looks really bad. So even searching on exchange rates doesn't even give me anything. So what's happened here is that RBA exchange rates. The RBA have changed their website to have a whole bunch of static HTML in it, and then once the HTML is loaded, they've got JavaScript in there to actually populate some of the things where the data changes all the time. So you can see here there's some JavaScript that they're doing to get the exchange rates, and then they fill out the placeholders with the real data, and that's where they put the IDs on the rows. Now this is a problem with Beautiful Soup. Beautiful Soup actually just grabs the HTML as it came, and as it came originally, not after the JavaScript has made any changes, because it's just going straight to the server. JavaScript runs in the client. We've got no way of running JavaScript inside Python. So what we can do in this case is we can see the HTML after the JavaScript is run just here. So we can actually select it. So if I select the table and right click on that and say copy the element, I've now got the table after the JavaScript has run, and I can store that into a variable. So let's see, I'll call it table equals, and then I used triple double quotes because there'll be lots of carriage returns and single quotes and single double quotes in there. But I could just store that as text and make my soup out of that. So if I run that and you have a look at my soup, now I've got rows with IDs on them, and I can run this same bit of code that we had before, and it's done a filter on those IDs just for the ones that are IDR and INR, and it tells me that INR is the Indian rupee and the IDR is the Indonesian rupiah. So that's a bit of a manual workaround in that scenario. What you could do is another solution is to use Selenium, and that's similar to what Arun was using in his machine learning session a couple of weeks ago. He used Selenium to actually generate the web pages. So he was getting the web pages after the JavaScript had run and populated some of the more dynamic data, and then he was screenshotting that. So we could use Selenium. There's I'm not going to go through it tonight. It's a fairly big topic, but we could use Selenium to run that link in a web browser, and then Python can communicate with the Selenium to get the data out of the web page. Alright, so we've got a couple more tasks here, just to show you a couple more different things, different ways of doing things. So from the RBA page showing those rates over the last 3 days, find the currency where the rate has both increased and decreased over that time period. So what this task is doing is showing you some even more complicated filters that you can use when you're using the find command. And this one is an example of using a callable. So a callable is a function that you can call. I've created a function here called procrastinate, which is like a play on words, so it's a procrastinating rate. It's going up and down over 3 days. And when I do find all, I can just pass in the name of that function, and Beautiful Soup will call that function, passing in an argument of the tag, and the tag's going to be the row. Well, the tag is, let's see, I'm only interested in rows, so if the tag is not a tr, I'm just going to return false. So this function has to return either true or false. So if it's not a row, return false. I'm not interested in anything but rows. If it is a row, then I look at the data cells in it, the TDs, and I check the 3 values, R1, R2, and R3, and I just see if R1 is less than R2, and which is greater than R3, so that means it's gone up and then down, or it's gone down and then up. And if either of those cases happen, then I'm going to return true. Oh, and I've converted them to floats so that I'm doing a proper numerical comparison. Alright, so if that returns true, then I will get my row stored in this list of rows, and then I can print it out. So these are the procrastinating rates. United States dollar, 6611 went up to 6615 and then down to 6614. Chinese went down to 4.74 and then back up to 4.75, and there you go, you can see all the data. Okay, and one more thing that you might want to search on, does a tag have an ID attribute? So I don't care what the attribute is, just want to know whether it has it. And the way you do that search is you just put a equals true in here, or you could do false if you want it to not have that attribute, and so ID equals true. So we're just finding all the attributes, all the tags that have got IDs, and there they are. They're only row tags. Well, we only had a table anyway, so there's not much in there other than the rows, but the rows had IDs, and that's how we were able to find what they all were, and ignore the individual TDs or the T heads or the table itself. Okay, well, I hope that's shown you some things that you can do with Beautiful Soup, and maybe yeah, if you've got some control over that. Remember to try to set your the way you're using the structure in a way that's not going to be dependent on an exact structure if you can, but well, I mean, if it's someone else's website, you don't have control over it, and so there's a good chance that you'll lose it. Beautiful. So Slade has sent a question here. Is Beautiful Soup good for mapping out the structure, all the pages of a website, or are there better tools? Okay. I guess you're good. Like it does show the structure. I don't know of anything that's better in showing the structure of within the pages. Like it's not going to show you the structure of of all the how the pages link to each other in like a sitemap. I think there'll be better tools for sitemaps, but within a page itself, it is a very good way of looking at the structure. Okay, well, I look forward to seeing you in person next week at Brisbane Business Hub, 155 Queen Street in the Brisbane City Mall, for our last ever in-person session at that venue. After that, we'll be going a month later in April. We'll be trying to do one down in the Fortitude Valley at the precinct, and we're still looking around. So if anyone knows of a good venue for us, let us know. I hope that's been useful, and I will catch you next time. Arun will be doing the session in person, so it'll be more a machine learning session, and he's been doing a lot of generative AI stuff.